Okay, as we discussed that there are four types of connectives in the mathematical logic chapter to combine two simple statements into a compound statement. You can have two or more simple statements connected to form a compound statement. So out of that, we're going to now first focus on conjunction. Okay, so conjunction is a compound statement where we're going to use the logical connective as and. The symbol will be this, but in statement we'll be using and. So let me take a few examples to make you understand how it works. So 2 plus 3 is 5 and 2 into 3 is 6. Okay, so we have 2 plus 3 is 5 and 2 into 3 is 6. Okay, I can put different versions of this. 2 plus 3 is 5 and 2 into 3 is not equal to 6. 2 plus 3 is not equal to 5 and 2 into 3 is equal to 6. 2 plus 3 is not equal to 5 and at the same time we say 2 into 3 is also not equal to 6. Okay, so these are the four versions which I have written down here. Okay, we can say the first statement in this is say P. Okay, we can call this as the first statement P. We can say this is the second statement which is Q. And what will be the symbolic form for this? You can say it is combined using and, so we can write P and Q. Okay, so we can write P and Q as a compound statement where the simple statements are P, the simple statements are Q, and what is the truth value? The truth value for P is true. Yes, it is T. Okay. Then we say the truth value for Q, 2 into 3 is 6, is a true statement, right? So we say Q is true. So P is true, Q is true, and we say the compound statement P and Q is also a true statement, right? Okay, I repeat again. When both the components of this compound statement, when both the simple statements in the compound statement are true, then the compound statement conjunction 1 is true. Okay, how it works? See, in this I have said 2 plus 3 is 5 and at the same time 2 into 3 is 6. When I say and, it is compulsion. It becomes compulsory that both the information provided by me is true, for the statement to be true. See, in the next example you will understand better how it goes. The next example says 2 plus 3 is 5, which is true, and 2 into 3 is 6, which is false. So when I say 2 plus 3 is 5, you will say yes, it is true. And at the same time I will say that 2 into 3 is 6. Listen, 2 plus 3 is 5 and 2 into 3 is 6. If I say that, okay, so you will say, sir, first information is true, but the second information is false, and therefore in this scenario, when I say and, it becomes compulsory for both the simple statements to be true. So in this scenario, we say the statement is a false statement. P and Q is false statement. Why P and Q is false statement? Because one is true and the other is false. Okay, same goes, yes, for the next example. You must have guessed by now. You are saying 2 plus 3 is not equal to 5, but that is false. And at the same time 2 into 3 is 6. So you'll say yes, this is false and this is true, but if you see the combined effect of the compound statement, we say it is a false statement. Okay, in this case 2 plus 3 is not equal to 5, false and false. Yes, so false and false, both are false. The statement becomes a false statement. So this is what we have prepared here is a truth table. It's a truth table in every scenario of P and Q. I repeat again, when I use word and, I have to be very sure about both the statements provided by me to be true, then only the compound statement has to be true. If either is false, the compound statement becomes a false statement. Okay, so in this case, when I say 2 plus 3 is 5 and 2 into 3 is not equal to 6, you will easily point out that, sir, this is true, but this is false. And therefore your statement that 2 into 3 is 6 is false, and therefore your statement, the compound statement where you said and, that when you wanted say both to be compulsorily true, becomes a false statement. Okay, so next I can relate this to set theory also. Set theory, in set theory, in the Venn diagram we have two sets A and B, right? In that, this is the region where you will say elements belonging to both A and B occur. So I am talking in conjunction, I am talking about this region, right? Symbolically in set theory it is called as A intersection B, right? So that region we are talking about when we say and as a logical connective between the two statements. One more thing which you can relate conjunction to is the switching circuit, where you have switches connected in series. When will be the circuit on? When will be the lamp which is connected on the other side of the network here be glowing? When the lamp will be glowing? So you will say both the switches has to be closed. If S1 is closed but S2 is open, it doesn't work. If S1 is open, S2 is closed, doesn't work. If both are open, doesn't work. It works only under one case. That is when both are true, the lamp is on. Both are true means both are closed, the lamp is on. Okay, so we quickly talk about conjunction again. Conjunction, the symbol which you are going to use is this. This stands for and, but still though many more words which we are going to use to connect two simple statements. And in this, what I have written is different examples and I have showed how it works. The compound statement also has a truth value, but the compound statement's truth value depends on the truth values of its simple statements. In this, when both the simple statements are true, then only the compound statement is true. Otherwise, you have to take it as a false statement, because for compound statement to be true, this is the region where I'm shading. In set theory, your elements should be part of both A and B at the same time. You can't say this region is belonging to the intersection. This is only A. That won't work. Only B will not work. It has to be both A and B. It has to be both the switches closed. Okay. So that is conjunction. Next, we are going to do the second logical connective, that is disjunction. Okay. So I'm not making much changes here. We can say for disjunction, yes, the symbol changes to or. This is standing for or. So here everywhere ready to put or now. That's it. So 2 plus 3 is 5. Or. Okay, this becomes or. Okay, so in disjunction, when you are not sure, you use the word or. I'll say when you are not sure about the things, you use the word or. When you are sure about the things, you use the word and. The this is true and that is also true. But in this, what you'll do is you'll say 2 plus 3, either 2 plus 3 is 5 or 2 into 3 is 6. I'm not sure. Right? Either this is true or that is true. I'm not sure about both the things. That is when or comes. Or is like when you're in doubt. And is when you're firm about the things that yes, this is how it is going. It will go, right? So that is what is done here also in mathematical logic. The same thing is applied. So when you're saying 2 plus 3 is 5, it is a true statement. When you're saying 2 into 3 is 6, it is a true statement. And then you can say the compound statement using or is also a true statement. Okay? In this 2 plus 3 is 5 or 2 plus 3 is not equal to 6. So when I say 2 plus 3 is 5, it is a true statement. 2 into 3 is not equal to 6 is a false statement. But yes, you said or. So I don't know, either 2 plus 3 is 5 or 2 into 3 is not equal to 6. One of the two, I don't know which one. So when you say or, it is like that, one of the two, and you have an option, you can say chalega. One is true, it is true. Because you already said, I don't know, it is either this or that. Either this or that. Again, you get the answer as true. In this, but both are false. So then when I say 2 plus 3 is not equal to 5 or 2 into 3 is not equal to 6. So when I say either this or that, but you will say no, both are wrong, and therefore the compound statement using or becomes false under one category, that when both are false, the statement is false. Okay, I repeat again, when you say or, you have an option open. Even if one is true, you get the statement as true. But when you have made both the statements false statements, then obviously or will also not help you in you have the compound statement as a false statement. Okay. In set theory, yes, in set theory, you can show a region which is A union B. So A union B is like you can combine both the regions as well. This is what you're talking about. So it can be either A or B, but only A or only B, or you have both. Right? That is what I'm talking about. These are three cases which you have shaded here. You can have only P true, you can have only Q true, you can have both true, but you can't have both as false. This region won't be counted. So we can always relate mathematical logic with set theory. This A union B is also called as A or B. See, or. In the previous example, I said A and B. When I say A and B, then it is intersection. When I say A or B, it is disjunction. It is union, okay? And then I have an example of switches. Yes, already we have done this example during conjunction. It is very simple to understand, so I'll go fast this time. When I say, sorry, this is conjunction. Conjunction, for that it is series. But when I say disjunction, you can take an example of switches connected in parallel. Okay, in parallel. So when the current is flowing and you say S1 is closed, current वहाँ से निकल जाएगा, lamp is on. If you say S2 is closed, lamp is on. If you say both are closed, lamp is on. If you say S1 is closed, lamp is on. If you say S2 is closed, lamp is on. If you say both are closed, lamp is on. But when you say both are open, then how is the current going to flow? So in that case, we say it is a false statement, the lamp will not glow. So the parallel thing you can remember as the truth table of disjunction. It is similar. S1 closed chalega, khali S2 closed भी chalega, both closed भी chalega, but when S1 and S2 both are open, then lamp won't glow. Right? Both false नहीं chalega. Same thing. Right? This all three are the examples for disjunction. So conjunction, both true, then only true. Disjunction, both false, then false. Right? In conjunction, if either is false, the answer is false. In disjunction, if either is true, the answer is true. Okay? Very easy. The next logical connective which we are going to learn is a bit important one, and it's a little tricky also to understand. So I'm going to take a